Hi everyone, and welcome to day 8. This is a pretty fun puzzle. I actually tried to do it live, and it went pretty well the first part, and then ran into issues, and just decided let's just make something really short and concise and walk you through kind of the solution here, along with something fun along the way that might happen. Just to give you a sneak peek, I solved the second part using one approach that I actually think is going to work. It's a terribly long, slow process. It's running right now, and there's a chance that it might finish when during this recording. So I'm going to keep that one running and explain the difference between them. The real solution that I use happens way faster, a lot smarter way to do it. So all right, let's go into this. So basically, it's this haunted wasteland thing. You're kind of given these nodes that this is kind of the location on like a map, and you're also given a direction. So like this is going to the right, then going to the left. This being the right, this being left. So if your first direction, if you're starting at AAA, and your first direction is right, you would then go to CCC. Then this increments to be left. So from CCC, you would then go to ZZZ. Then it goes back in the loop to right, and so on and so forth. And the idea is you're starting at A and you want to get to Z, and we got to figure out the longest or the shortest path to do so. So I came up with a solution here, and we'll just put it back to ground truth, and we'll just run it real quick. This would be, what are we, December 8th, we'll see we get the 6 back as they say. Because in the example, I kind of walked you through it. You basically just keep following that. We're counting the number of steps it takes, how many turns. So basically we just import the file just as normal, and our solve function, this is pretty basic. First we just want to get the directions, so we actually just take the first line, we trim it just in case it's a leading space, and then we split, and that will get us the R and L. Keep in mind, in the real data, you're going to have probably something like R, L, 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 R, R. Like it'll be a really long, really long version of it, just to kind of show you what that might look like. We have, a really long thing. So we also then do this thing called parse line once we have the directions. And this parse line, it's creating this object called a node, which stores basically the location, the left and the right thing. And the parsing is pretty, although it could probably be done with a regular expression a lot easier. I'm just doing some lovely trimming and replace alls and converting it to a list. So we get this node, which has a location, a left and a right. So those are our nodes there. And first of all, we want to get our what I'm calling the current node, and at first that's going to be the first node that starts with that is AAAA, and hopefully there's just one of them in, and if not, I don't know, it's just gonna get the first one, I guess. But we get the first one. Then we're going to be incrementing 2 different things. Although after kind of rethinking this, these we could probably actually use the same variable here. But whatever. So we're starting at 0, and we're just doing a while loop. And basically what we need to do is we need to get, based on that I, what direction are we at? And because this is, in theory, this only has 2 directions, we need to loop this list. So I'm actually just doing a mod on it to basically get the remainder. And if it's less than 0, we're adding it in. So this will just make it actually kind of, anytime we get a direction from the direction index, will essentially be, the first one will be R, then it will be L. And if this was 4 things long, RL, RL, you would get RL, RL, and then on number 5, you would get R again. So it's just a way to kind of easily do a loop. And then I'm just creating this string. It's a late string because it will not be null, but it isn't set at this point. So if the direction that we got back is L, we want to look at the current nodes left. And this is just the move to. Otherwise we want to look at its right. And basically at any point, if we get a move to that says it's ZZZ, yes, I'm Canadian, we will have, we know we're there, and we break out of this loop. And because that steps is getting incremented every time, oh yes, this is the reason I didn't want to increment it is because technically steps I want to increment right off the start. Whereas I, meaning the, for the directions, I don't want to increment to the end. So that's the reason why they are 2, just to keep it simple. But basically this will keep incrementing, and then we return that. And this one, yeah, pretty basic. We get back the 6. I plugged this in with my, real data and got a much larger number. Takes a little bit longer to run, and, was able to get that pretty quickly. No real problems there. So part 2 kind of changes things quite a bit. essentially what they're saying now, where's part 2 start, is there's going to actually be multiple starting nodes. Every node that ends in an A, whether it's like BBA or 11A or whatever, is a starting node. So there's actually multiple in this test data. There's 2. And then there's also multiple ending nodes, Z and Z. So what we need to figure out is, assuming all these moves are happening kind of at the same time, we need to find out when will all of them be at the end at the same time. So it's not as simple as, okay, we'll just find, the smallest number or the largest number, I guess, of these steps. It's not like you stop once you get to the end. You only stop the loop if everyone's at the end. So I'm going to quickly walk you through my first attempt at this, which is the one running right here, which, I don't know, there's a slight chance it might pop out an answer by the end of this. But basically it starts the same. The main difference is we actually need to know which the starting nodes are. So I added to our class just some getter, an is starting node, is ending node, which just looks at the last character and sees if it's an A, we know it's a starting node. If it ends in a Z, it's a ending node. Just easier to work with, because then we can just do something like nodes where n.is starting node, convert it back to a list. And then I had this function called min steps. And what I'm passing into here is the directions. That's just the list of L's and R's, the starting nodes, and the all the nodes, because the program needs to know the data here of the entire place set, not just the ones that are starting. And again, this is the first attempt here, and basically is running right now. And we still do the while loop, we set the direction and stuff, and then I loop through all the nodes and kind of do the same sort of logic that we would want. And then at the very end, we actually swap out whatever in this list of starting nodes at whatever n we're at, we remove it and replace it with the new version of it, right? So this loop will keep going. Keep going. And what I do then after this for loop, but still within the while loop, is we count how many are at the end. And in this case, and that's what's being printed out actually right now. I'm only printing when it's greater than 0, just because otherwise it's just a ton of zeros. And if the total at end is equal to the number of nodes that we started with, so this length and this length, we know we can break out. And we're incrementing the steps as we go, so we return steps after this loop goes. Now, the problem with doing this way is we're calculating, all these things ongoingly, and I realize there's a better math solution here, because we could kind of actually, instead of calculating them all together and moving them all together and being like, hey, are you all there? Are you all there? We can actually just find out, okay, how many steps does it take for each of these individually? And then we can find what is the lowest common multiple of that, which is like a math term for finding, the lowest number that basically goes into all these. And that's really what is being calculated here, just in a terrible way. So the way I actually kind of refactored this is this loop now, or the min steps function that we were looking at before, it no longer loops through the nodes. We're only passing in one node. And so this works a lot like part A, where we're just getting a number. The little bit of differences because we need to know if it's like a starting node or an ending node. And then basically at the end of the loop, we get the ending node. So if I run this, let's run this against ground truth. And I have a couple other things printing out, but basically, actually, yeah, we don't really need that print there, and we don't really need this. Basically, it's going to loop through the nodes and call that one function. So you'll see when we spit this out, we actually get these are all the steps. So the first one took 2, and the next one took 3. And this lowest common, I made a function here. First of all, there's a LCM, and I just kind of found this online of how to find out the lowest common multiple of 2 numbers. So I made that, and then I made something that actually allows you to pass in a list of numbers and essentially just loops through and finds them all. So that we can pass in a list, and that actually will give us the number 6 in this case. So because 2 times 3 is 6, that's not the calculation for a lowest common multiple, but in this case, it's easy to say. And then, we get that number back, and compared to this one that's running right here, if I change this back to false, and basically what we get back still a little bit slow, but that was, way faster than whatever's happening over here. We got these numbers back, and then when you run this into the lowest common function, lowest common multiple function, you end up getting, this number back. So this is the number that is, if you were to, it's basically the number that all of these numbers can evenly go into without a remainder. It's the lowest one. There's obviously multiple things that it could be, but we want to know what the lowest one is. Yeah, so there we go. There's the solution for today that I came up with. Again, please try these on your own. New one every day until I assume the 25th. And it's been fun so far. So I'll see you in the next one.